our first proof is it's going to be a straightforward one. It looks like this on the sheet, and I'm just going to show this one here. First thing I would do with the proof always is write down my given. So I'm going to look at this and say, well, here's what I'm given. I'm given that BC is congruent to DE, and that AB is congruent to AE, and these are both given. Okay, so those 2 points I'm given here. From here, I kind of outlined on my diagram here that AB is congruent to AE with those little lines, and that CB is congruent to DE. They ultimately want me to prove that this long segment AC is congruent to DA. Okay, so let's see how we can do that. So given this first parameters here, the first thing you would do here is get out of the congruency. And so I'm going to move this all the way to the equal sign. So what I'm going to do here is say that BC is equal to DE. In other words, the length of each one are equal. As well, AB is equal to AE. So that should have a line above it. And those are now going to be equal. And the reason is the definition of congruence. And I read it something like this, the definition of congruency. Okay. Now where to go from here? Well, I have to look at where I'm going, and I know I need to ultimately get AC and AD, and that's these big long segments. I know that they're made up of these little segments, so why don't we use that to our advantage? So what I'm going to do is I'm going to say here that AB plus BC is equal to AC, and similarly with the other side. So let's take a look at that. It's going to say here that AB plus BC is equal to AC. Similarly, I'm going to say here that AE plus ED is equal to, I guess it would be AD. And this is from the segment addition postulate. And both these reasons are exactly the same. Okay, both these reasons are exactly the same. So now from here, now that I have the segment addition, I'm going to look at what I can do in common here. So I look and I say, okay, I know I want to get AC and AD, or what they call DA, same thing. So AC and AD, how do I get these guys to match? Let's see. In fact, I'm just going to change this and call it DA just to match up with the wording of the text. So I'm going to call that DA. Now, how am I going to get these to match? Well, let's see. I know here that BC and DE are the same. So in other words, right here, this is DE and BC. They're exactly the same. And AB and AE are the same. So I'm going to substitute here and say, rather than writing AB, rather than writing AB, I'm going to write in, so I'm going to take this down here, I'm going to write in AE, because I know they're the same. Rather than writing BC, I'm going to write DE. Okay. I'm going to call it ED, just for the sake. And I'm going to say that that's equal to AC. The reason I do that is now it's very obvious why these are equal to each other, because they're equal to the same thing. I'm going to call what I just did there a substitution property of equality. Okay, it's a substitution property of equality. Now that I know this, I can actually substitute, instead of writing AE plus ED, I can substitute in AC, in which case I'm going to get here AC is equal to DA. And again, that's another substitution property of equality. Lastly, knowing this, I know I had to get to, just to remind myself, I had to get to this, and these are congruency. So I take it and I say that AC is congruent to DA by the definition of congruence. And we're finished with that one there.